You'll need a calculator eventually, but what we're going to be looking at is this here. We want to find a number when multiplied by itself, you get a negative number. So what would be an exemplar thing that we could try for this here?
Multiplied by itself. So it's positive. Multiplied by itself, it's negative.
So yes. So we're trying to find a number when multiplied by itself, we get a negative number. So let's say 2. Well, 2 times 2 is 4. Okay, well that didn't work. Well, we can try negative 2 times negative 2 would be? Because our negative times a negative would make a positive. So really what we're wanting, and neither one of these worked, is let's say 1. We need to multiply a number. Let's just call it I. We'll imagine this number, when multiplied by itself, squared, would give us a negative 1. Because we're trying to multiply a number by itself and get a negative. Which means, if we take, say, the square root of both sides, because here the square root and square would cancel, telling us I, this imaginary number, would be the square root of negative 1. Because that's the only way that this is going to work. And really, this here is actually our imaginary number I. I is, by definition, the square root of negative 1. And that's our imaginary number I. And this is when our non-real solutions, our imaginary solutions come in. This is how we solve those there. So our imaginary number I is, by definition, the square root of negative 1. And that helps us solve some of these here, because that's some of the issues, like the problems that we had up to this point, where we took the square root of this negative number and didn't get a real solution, because I is a part of that solution. So up to this point, trying to take the square root of negative 25 didn't work, because we can't have a number times itself that gives us negative 25. Now, by what we have and what we just found is that we can now take this, because really we can think of the square root of negative 25 as 2 parts, because we have the square root of negative 1 and our square root of 25. Now, according to our properties of radicals, we can break this up as the square root of negative 1 times the square root of 25. Well, what is the square root of 25? 5. Because 5 times 5 is 25. The square root of 25 is 5. Questions on this so far? Now, what's the square root of negative 1? I. Because by definition, I is our square root of negative 1. So what we're saying is that the square root of negative 25 is 5i. Questions on this here? Now, luckily for us here, the graphing calculator does work with I. So parentheses, 5, second decimal. And we can say 5i squared. And if we multiply 5i by 5i, we do indeed get negative 25. Need a note sheet. So, the square root of negative 25 is 5i. Questions on this so far? Are you ready for the next one? Square root of negative 72. Now again, we can break it up like we've done so far. So we can think of it as the square root, guys, let's focus in. Square root of negative 1 times 72. And just like we did before, we could break this apart and say that we have the square root of negative 1 times the square root of 72. What is the square root of 72? What times itself is 72? Is there a nice number that multiplies by itself and gives us 72? Well, no, but it can reduce. And there's different ways we can do it. One of them is finding our perfect square factors of 72 that work into 72 and reduce it. Or the other way we can do this is use the 30xs, because the 30xs will leave it in simplest radical form. Because we can say second square root 72, and the square root of 72 does simplify to 6 square roots of 2. So the square root of 72 is 6 square root of 2. Questions on how we simplified that? Because really what we're doing with the square root of 72 is finding its factors. Because square root of 72 is 2 times 36. We can't take the square root of 2. And what is the square root of 36? 6. So our square root of 36 is where we get the 6 from. And since we can't take the square root of 2, it stays inside the radical. Questions on this so far? Well, we're not quite done because we still have what? The square root of negative 1. And what is the square root of negative 1? I. So the square root of negative 72 is 6i square roots of 2. Questions on this here? We ready for the next one? Because the next one we have is negative 5 times the square root of negative 9. So, well, we still have the negative 5, but we do need to reduce or simplify our square root of negative 9, yes? And we can do like we've just been doing. We split it apart because we'll have the negative 1 and the 9, yes? But what's going to happen with that negative 1? It's going to turn into what? I, yes? So really we can think of this as two parts because we do have the I. Take it out, which just leaves us with the square root of 9. Because that negative inside an even root inside this radical is going to come out as I. Now what is the square root of 9? 3. So that would tell us that the square root of negative 9 is 3i. The negative comes out as I, and then we can take the square root of the number. Questions on this so far? Questions on anything we've done so far? Now what's the square, or negative 5 times 3i, or negative 5 times 3? Negative 5 times 3 is negative 15i. Or really, we could have just taken what? The 30xs, this calculator here. So if we plugged in negative 5 square root negative 9, it gives us an error. And the reason it gives us an error is because the negative inside the radical. But we know that negative is going to come out as what? I get rid of the negative and let it do everything else. So it tells us negative 15, yes? But it should be what? Negative 15 I. We just put the I back in, and we're done. Now the graphing calculator, let's see what it does. -5, second square root. It tells us it is indeed 15i, -15i, yes? So the question is, why don't we always use it? Well, square root -72. This is the one we did just before it, yes? And we found the answer to be what? 6i square root of, and it tells us it is this here. Well, that is the same answer, 6 square root of 2. Well, we can say 6i square root of 2. We do get the exact same answer, but it doesn't leave it in simplest radical form. It turns it into a decimal. So if the radical works out nicely, it is a perfect square and reduces, the graphing calculator works nice. If it doesn't reduce nicely, well, then we've got to find it in simplest radical form. 30xs works a little bit better. So let's look at these here. So we're looking at the square root of -4. Well, we know the negative is going to what? Come out as I. So really what we're looking at is what? The square root of 4. What's the square root of 4? 2. 2 times 2 is 4, yes? So what's the square root of -4? Square root of -4 would be 2i. Questions on this here? We feel all right with this. It is a weird concept because we're talking about I, this imaginary number, as the square root of -1, which is a little weird, but there's not that much to it at the same time. Now, if we look at the next one, square root of -12. The negative is going to come out as what? I. So the negative comes out as I, really leaving us with trying to find the square root of 12. Now, to find the square root of 12, we'd find the perfect squares. We just use the 30xs. It tells us it is 2 square root of 3. So the square root of 12 is 2 square roots of 3. But for our square root of -12, it would be 2i square root of 3. Because the I is always going to come out of the radical. Questions on this here? We ready for the next one? Negative square root of -36. Well, the negative is going to come out as I. The negative comes out of the radical as I. Leaving us with what part of our radical? The square root of 36. And what is the square root of 36? 6. Yep. So it would indeed be -6i, because the negative out front of the radical still stays. There's nothing changing it, so it's still part of our answer. So we have -6i. Now we could have done that in the calculator. The 30xs is negative second square root. 36 does give us -6. We just have to put the I back, giving us our -6i. Questions on this here? Questions on anything we've done so far? Our next one, 2 times the square root of -54. the negative would come out as I, so that's part of our answer. And the last thing we have to reduce or simplify is our 2 square root of 54. I think there's a good chance the square root of 54 is not going to reduce nicely. We'll still have something left in the radical. Yeah, we can put it in the calculator. 2 square root of 54 is 6 square root of 6. Now for our answer, we still need that negative, that I term back in, so it'd be 6I square root of 6. Because 6 square root of 6 squared would get us back to our 2 square root of 54, not our 2 square root of negative 54. We need the I to get back there. Questions on this here? Questions on I so far? So I does work, is interesting. It does have some interesting properties with how it works. Now we're going to look at some of the other properties, and the first one is going to be powers of I. Well, we know I is by definition equal to the square root of negative 1. Now what we're about to do and what we're going to be doing with this here might seem a little weird, might seem a little strange, but it is going to make sense in a minute. Just follow along with me with this here, because we're going to be multiplying I by itself a whole lot. Now I squared, what we're really saying is that we're taking the square root of negative 1 and squaring it. We're multiplying the square root of negative 1 by itself. Well, here this square root and square would cancel, telling me that I squared is negative 1. So I is our square root of negative 1, or just I. We multiply it by itself, we get negative 1. Because I squared I times I would give us negative 1. We're going to multiply it by itself 3 times now. I to the third. Well, really, it is I cubed. Really, we're just taking the previous one, I squared, and multiplying it by I. Well, what is I squared? I squared is negative 1. All right, guys. So what we're really saying is that we have negative 1 times I. And negative 1 times I is, well, so I to the third power ends up simplifying to negative I. Okay. Almost, except instead of negative 1, it is negative I. You're good? But I would be looking for patterns here. Now, I to the fourth. Well, I to the fourth is just, there's different ways we can break it down. But we're just taking whatever I to the third, because we multiplied it 3 times already, and multiplying it 1 more time. Well, I to the third is negative I. We already found it, because that's the previous one. So we're taking that negative I and multiplying it by I. We'll still have the negative, but I times I is I squared. Well, what did we say I squared was? I squared is, so what we're saying is that we have negative negative 1, which is just 1. Okay. This might seem a little weird, but again, as I said, just hold on. We're going to be getting somewhere here in a second. Questions on this so far? Okay. I to the fifth. Well, I to the fifth is what? Going to be I to the fourth times I. Well, what did we say I to the fourth was? So I to the fourth is 1, so we're saying 1 times I, which is so our I to the fifth is the same as just I, yes? Okay. It will start repeating itself because if we look at I to the sixth, I to the fifth times I, well, I to the yes, it is basically going to restart because I to the fifth was I times I is I squared, which is -1. So I to the sixth is going to be the same as I squared, which is -1. What do we think I to the seventh is going to be? Negative I. Because it'd be I to the sixth times I. Well, I to the sixth is -1. And -1 times I is -I. What do we think I to the eighth is going to be? 1. Because I to the eighth would be, there's different ways we could have broke it down. We could have said it's the same as I to the fourth times I to the fourth. 1 times 1 gives us 1. I to the seventh is -I. Times I would give us -I squared, which gives us -1, which is 1. Now, hopefully, I think y'all have seen the pattern, yes? No matter what power of I we have, it's going to give us one of 4 options. Either I, -1, -I, or 1. Because whenever we have an I, an imaginary number, I, to a power greater than 1, we have to reduce it to one of these 4. Now we have this here. And really what this is saying, and this is kind of nice and handy, we can write this here with it, I to the n. Whenever you're given I to a power, take whatever that power is and divide it by 4. And we're going to get a number point decimal. Now if the decimal is 0.25, then our power of I is going to reduce to I. If the decimal is 0.25, it's going to reduce to I. If the decimal is 0.50, it's going to reduce to -1. If the decimal is 0.75, it's going to reduce to -I. And if the decimal is 0.00, or there is no decimal, then it's going to simplify to 1. The number in front, the whole number, does not matter. We're just purely looking at the decimal. Which one of these 4 decimals is it? Because if our power of I I to the n. If we take that n and divide it by 4, and our decimal number is 0.25, is going to reduce to I. If the decimal is 0.50, it's going to be reduced to -1. 0.75 is going to be -I. And 0.00 is going to reduce to +1. Okay. Questions on this here? So, go on and grab a calculator. You don't need the graphing. Just go on and grab a 30XS so we can do this together. Yeah, someone's borrowed. So, the first one that we want to evaluate is I to the 27th, I to the 27th power. Now to do this, we can take 27 and divide it by 4. So we can grab the calculator, do 27 divided by 4. Because I think that is what, 6? So when we do this, we do get 6.75. Now, so if we look at that there, 0.75 is -I. So it tells us that I to the 27 reduces to -I. Because we're not too much concerned about the 6. 6 just tells us we go through this cycle of 4 6 times. But our I to the 27th gives us -I. The 6 doesn't really matter. It's all counting the cycle. It says we went through this cycle of 4 6 times and then went 3 more. Questions on this here? So let's look at the next one, I to the 34th. So we're going to take 34 and divide it by 4. And 34 divided by 4 is 8.5. So I to the 34th would indeed reduce to -1. I to the 47th. So we're going to take 47 divided by 4 and get 11.75. 11 really doesn't matter. We're more focused on the 0.75. And so I to the 47th reduces to -I. Our next one is 65. I to the 65. So we had something 0.25. So I to the 65th reduces to I. And lastly, we have I to the 1040. So what was the number? 260. Now, it didn't give us a decimal, but it's understood to be 0.00. So this just reduces to I. Oh, 1. Thank you. I don't know why I flipped that, but that should be 1. Yes. Thank you. So it's 1. Questions on this here? Yeah. Now, we can type I into the graphing calculator. So if we said I to the, I think the first one was 27, yes? It tells us it is negative I. I to the 47 is negative I. And this works well. So the last one, all right, I to the 1040 1 plus 4e to the negative 12i. So, all right, guys, let's focus in. Well, it said 4e negative 12i. All right. So most of those that we did, I tried a few of them in the calculator and it gave us answers. But this one here gave us this here. Now, the graphing calculator, what it means by E is that means it's multiplying 4 by 10 to whatever the number is after it power. So we're saying 4 times 10 to the negative 12 I is what it's saying for this here. Now, for us here, when we have a negative power, all that's saying is that we're taking the decimal point and moving it to the left. So here we're moving the decimal point 12 spots to the left, which would give us 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. All right, so we're saying we're having 1 plus that very, very, very small number I. And for us here, in all case and purposes, this is 0, so it's really just telling us that it is 1. So for some of this, the graphing calculator can take I to a power and reduce it, but once it gets too big, really what it's doing is graphing and approximating. So the pixel error that comes up with this here is this here. So our answer is just 1, or we could have just divided the power by 4 and got to our answer a lot nicer, a lot quicker. Questions on finding powers of I? Are you ready for the next part? Yep. Sum and difference in complex numbers. All right, guys. To add or subtract two complex numbers. Add or subtract their real parts and add or subtract their imaginary parts. Yep. Yep. Now, I wouldn't focus too much on writing that there. Let's see here. Let's look at the problem. Yeah. 8 minus I plus 5 plus 4I. Now, since here we're adding, the first set we can just drop the parentheses. We have 8 minus I plus 5 plus 4I. Since there's not a negative sign in front of the parentheses or a number in front of them, we can drop the parentheses. So it just gives us 8 minus I plus 5 plus 4I. Well, 8 and 5 are like terms. I'm going to move them next to each other. And our negative I plus 4I are like terms. Can we agree with that there? They both have I, and our numbers are both are. 8 plus 5. So that's 13. Positive 13. Negative I plus 4I. And it would be a positive. We can say 4I. So we moved it around Yeah, we can just write it. I write it with the curl just to signify that it is our imaginary term I. Mm-hmm.
I keep doing the curl and I'm done with it. I give up.
Yeah. No, that's fine. As long as you're able to know that it is I. The other way that I is written is I with a kind of hat is another way that I is written. No, that's another way we can see I. Now the way we went, I think there's a question for how we went from here to here. Conley, I think you asked how we went from, really this here, I'm just rearranging. Because 8 and 5 are like terms and they're both positive. So I just moved it so they're next to each other. Our negative I and 4I. So I switched it around so we have our like terms next to each other and then we can combine. 8 and 5 gives us 15. Our negative I plus 4I, 4I minus I gives us 3I. So our 8 minus I plus 5 plus 4I is our 13 plus 3I. And that's as simplified as it gets, because 13 and 3I are not like terms because of I. That's square root of negative 1. And we get this here. Because the 3 is positive, and that negative that is with the square, with I, is stuck inside that radical. So it is the square root of negative 1, but that negative stays inside the radical. So we don't have to worry about that there. Questions on this here? We ready for the next one? Now let's look at this here. So our 7 minus 6I does not have a number or sign in front of it besides positive 1. So it's going to say 7 minus 6I. Now the second one, we're subtracting it. We have that negative in front, so we do need to distribute that negative across the parentheses. So our positive 3 is going to become negative 3. Our and our negative 6I is going to become positive 6I. Yes. All right, guys. Now our first set of like terms, 7 minus 3 is 4. Negative 6I plus 6I is, so our answer is 4. Questions on this here? 29. We ready for the next one? Yes? 13 minus 2 plus 7I plus 5I. Well, the 13 stays. We do need to distribute this negative through the parentheses. Now, this is kind of nice because our like terms are next to each other. 13 minus 2 is negative 7I plus 5I. Negative 7 plus 5 is. So we have 11 minus 2I. Now, if you notice, for the most part, we can treat I like we would a variable for the most part. Yeah, it's like an x. But the only difference is that this has a set value of square root of negative 1. The only time we have issues with I is if I gets an exponent greater than 1. So we look at I squared.
Put it in the calculator with I as like what it actually was, and then find figure.
So the last one was 13 minus, what was it, 2?
13 minus parentheses plus 7 in parentheses
Plus 5I.
Use a graphing.
The graphing calculator, yes. So the last one, 2 plus 9I. 2 plus 9I. Plus, what was it, 11 minus I? Minus I is questions on this here? Yeah, there should be. So here, if we did this by hand, we'd have 13 plus 4i minus 8 minus 13 minus 8 is 4i minus 4i is. So it tells us that the correct answer is 5. So 16.
Already separated first, so that's pretty.
So the first thing we would do is distribute that negative through. 16 minus 13 is? Negative 6i plus 8i is? Plus 2i. And again, we could have typed that, both of these here in the graphing calculator. The graphing calculator would have done it for us. Now, I will say, I'm going to go all the way back to the front. Most of these here, when we type the radical in with the negative, there's one thing about the graphing calculator we have to make sure of. And we can look at this again tomorrow. Mode, down here where it says real and a plus bi, if it's set in real, it's going to be looking for real numbers, real solutions. This is part of the reason why the 30xs, the yellow calculator, does not take the square root of a negative, because it's set to only be in real numbers. It will not do imaginary. So that's why it gives us an error. But doing all of these operations here, it doesn't matter if it's in real or a plus bi form. Now, we didn't finish the lesson today, and that's fine. We will finish up multiplication to tomorrow, and then we will be